Okay, here we are back again. We're now on page 16 of our statistics class notes. We are still talking, we're in section 2.2, talking about how to summarize what we see with a numerical distribution. So remember, we're talking about shape, center, and spread, and we're still talking about shape. The first thing we talked about in shape was whether it was symmetric versus skewed. Next thing was how many mounds does it have? Is it unimodal, bimodal, or multimodal? And the last thing is outliers. Uh, so here on page 16, extreme values are what we call outliers. They're extremely large or small values. They're data values that don't fit the pattern of the rest of the data. And right now, I'm just going to leave it really not precisely defined. It's kind of subject to opinion. So you just kind of look for stuff that's, you know, separated away from the rest of the data. We'll have a rule of thumb later, but for now we'll just say it's, kind of looking at data and have an opinion on whether it's an outlier or not. So in example 18, here's a histogram with some outliers. When you see extremely large or small values, we want to report those values. So notice that most of the data is in here. So this is salaries of something. And most people are down in here. And then we have somebody making kind of an unusually large salary as compared to the rest of the data set. So we want to report that it seems like it's away, it's an outlier. Realize that it could be a source of error, right? It could be that somebody just put a typo and didn't record the data set correctly. So we have to kind of think about, does it make sense or not? But genuine outliers are unusually interesting, and we don't really want to throw them out if they're really correct data values. So recall, shape was symmetric versus skewed, modes, and outliers. Now remember, with numerical data, we want to look at shape, center, and spread. Oh, I'm sorry about that. Get that out of there. Okay, so now we want to look at center. The second thing we want to classify when we're looking, or summarize when we're looking at numerical distributions. So center just means what's the typical value. And for the most part, when you're looking at, let's say, histograms, you just kind of think about a balance point. Where is the histogram balancing? So in this example, we want to estimate the center, the typical value for each of these graphs, okay? This could be a single value or a range of values. Now, when we're on a histogram, we really can't give a single value because we can't see single values. We only see values, we only see bins that have all the values in that bin lumped in there. So if I were looking at a balance point, kind of think of it as a teeter-totter, right? Remember the seesaw growing up? So you kind of have heavier data points over here, so I kind of need to be move this way a little bit. You have some out in the end of the teeter-totter. Just where is this going to balance? And it looks to me like it's going to be in this bin somewhere, which is between $30,000 and $40,000. Again, these are salaries. Over here, I'm balancing over here somewhere between, and these bins we can see are 4 wide, so this is somewhere between 86 and 90.